Hey everybody, welcome back to the channel. I'm planning to do some experimenting in the future here with some sort of miniature hydraulic stuff. I want to start playing around with building some miniature hydraulic stuff for different projects. And I'm going to need a cutting tool to make my O-ring seats. So that's what we're doing today. It's going to be a big job, so let's get right into it. So here's my plan. I want to make hydraulic stuff and I want to have it sealed with an O-ring. That one right there, to have different flanges and things. And so I want to make a tool so the hydraulic seal can happen when this O-ring fits into a groove and a flat plate seals against it. So to do that, I'm going to need to make this tool. This tool is going to consist of a drill bit. Some of it's going to do drilling, and I'm going to use part of its shank as a pilot. Now that's not going to make a super duper great pilot. So I'm going to make these teeth here that are doing the groove self-centering, and it should all work out fine. The body of this thing is going to be a piece of 4140, and that's shown in here. And this is going to be a depth stop because, of course, depth on this is going to be very critical. So there's our depth stop. And these teeth are going to be made out of carbide. So there's our carbide. Oh, and there's going to be a set screw to hold the drill in, and another set screw to hold this depth stop in place. So to do this, I'm going to be using a center drill, a clearance drill, a tap thread drill, a couple of taps, starting, finishing, turning tool, and a part off tool. It's going to be a big job, so let's get to it. Oh, one last thing. This is going to represent our hydraulic stuff. I've added a couple of numbers to my drawing, my sketch, and as so many stories do, this one begins in the bandsaw. Just going to clean this face up, get that running nice and true, and then we'll do all of our measuring from that face. Just got a bunch of turning to do now to bring us down to our first diameter, which is going to be 5/8 of an inch. So some nice soothing chip production. Not getting crazy fussy with this particular diameter. The OD, the outside diameter of this particular diameter, is irrelevant. This is just a little lip to stop my depth stop from moving on me. When I'm actually using this for a job. Since I'm making the depth stop, I can make it to suit this, so it's pretty much all good. Next, I'm going to set up the length of what's going to become my shank area. Now, the shank's going to have 3 flats on it to fit in a drill chuck, so the diameter for the purpose of being a shank isn't critical, but I am going to rely on this diameter for holding in collets for different operations, and that's why I really want this to be bang on size. Just put a marker on these for touching off. It's easier to see the marker disappear than it is to see chips appearing. A little chamfer here to clean things up. I want the chamfer to be bigger than the depth of my flats, just so there's no sharp edges on this thing. Mostly for aesthetics. I'm getting ready to make the hole where the drill bit is going to live in this thing, and I want that to run as true as is humanly possible. And one of the things I've found that really helps with that is to drill your center hole. What I was getting ready to say is, after getting the center drill to the depth you want, just to let it linger there for a minute. So even if it's boring sideways a little bit, the hole will be as concentric as is humanly possible. I think I've had good luck with that method. Not my lucky day, folks. Broke a second center drill in there. So I think it's time we turn this thing around and start working on the other end. I believe, since this hole I'm putting in has to go all the way through anyways, I believe I can push this broken remnant of a center drill out from the other side. So that's what I'm going to try. Another thing I found helpful with really deep holes to try and get them to go straight as possible is to start off quite slowly and really let it stay self-centered, not just go hammering it in there. And so I'm going to do that. I'm also going to, peck lots. It's a pretty deep hole for this size drill. And I also want to mention that this is not our finished size. This is a 64th smaller. And so by running through reasonably quickly with the next size of drill, the finished size drill, hopefully it'll give me as accurate a hole as possible. I am going to be counting on this drill bit to push the broken center drill out of the other end of this thing. So, and I fully suspect that'll work. It may be a little harsh on the end of this drill bit, but such is the life of a drill bit. That pilot drill did manage to successfully, and I believe without damage, push that center drill out the end of this hole. So now I'm going to go with my finished hole size, which in this case is going to be 3/16 of an inch. I would ream this hole if I had a reamer this size, and I don't, so we're doing what we can with what we have. We made this brace tip carbide turning tool in the last video, and more than one person was disappointed that we didn't show using it. Well, the reason is because I already had something in here that I didn't want to mess with. Anyways, today's our big day. We're going to put this in and we're going to try it out for the first time. Just getting the very tip of the cutting edge right at center height, and we're good to go. I'm going to try and draw out for you the feature that I'm putting on this thing now. So I'm going to have a carbide tooth that does something about like this. And I don't want it sticking up all unsupported out in the middle. So I'll draw a side view now of here's the tool we're making. Here's one of the teeth that's going to be on there. I want metal in behind supporting the tooth. And so basically I'm taking the end of this now and I'm machining it down like this, and then I'm boring it out like this. So all this is going away, this is going away, and these little bits here are going to support the back side of these teeth. Next thing I need to do is bore this out so that I'm left with just a thin, basically 1/16 inch thick little ring standing up here. So this is kind of fun for me. I get to use a tool I made quite a while ago and haven't actually had an opportunity to use this end of it yet. So we're going to use this to bore this little guy out. Just going to get that set up and on center. If you're interested in seeing this build video, I will put it up at the end. And there's our little counter bore done. So I'll need to create some tooth faces in here, 2 of them. This is going to be a 2-flute tool. Here's our little tool body so far out of the lathe now. So this part here is going to get 3 flats and a set screw to hold the drill. What I'm getting ready to do now is put my tooth seats in here. I'm going to put 5-degree rake on the face of these teeth, and so I'm going to set up now to put those tooth faces in there. I'm getting set up to put my tooth seats into this thing. Now, I debated for quite a while exactly how I was going to do this, and I'm not crazy happy with my decision, but if you remember this wheel we recently damaged pretty severely, well, it happens to be a 1/16 of an inch thick, and I plan on making carbide bits a 1/16 of an inch thick. So, sorry old friend, this won't hurt for long. I do need to determine center, and so what I'm going to do, I'm going to use my height gauge. I know this is exactly 1/2 inch, or at least as close as I could possibly get it. And so if I come down 1/4 inch from there, that's my center. I can scribe that in there. This roughly represents the tooth seat that I'm about to grind. Imagine if this was the center line of the tool. In a perfect world, our cutting edge would end up right on the center line of the tool, and that way the face would pass directly through the center line of the tool, and This is going to be very challenging for me to get this groove in the right place. So if you look over here, you can just make out my layout line here and here aligned with this scale, which is on a square, so it's perfectly vertical. What I'm going to do is I'm going to bring my wheel in and I'm going to move my table outwards until the wheel just touches the scale. And that will let me know that the back side of the wheel over here is exactly on the center line of this part. And that, because this is a right-hand tool that cuts this way, that will mean that my cutting edge is exactly on center. Well, not quite. There is this little bit here where the carbide is going to stick up above the top of the raised steel part by about 0.010 of an inch. So I did some math, and this little dimension here is got a whole bunch of zeros in front of it. It's way smaller than I could ever hope to see with my eyes. So we're just going to call the back edge of the wheel on center good enough. So the back edge of the wheel is going to come in here and cut this, and the opposite side of the wheel is going to cut this, and then my carbide blank is going to get soldered right into there. Hope that makes sense. Okay. For better or worse, that's as close as I am going to be able to get that. I'm attempting to confirm by eye that this is not grossly out of whack in any way, and struggling to see. And one thing for peace of mind that you can consider is, in machining, there's no such thing as perfect. And I mean, any seasoned machinist will tell you that. There's tolerances, yes, but there's no such thing as perfect. I mean, once in a blue moon, you'll completely fluke out and you'll get something perfect. But generally speaking, there's tolerances and you work within them, and that's the best you're going to do. So I won't be fretting over perfection here. If my tooth face isn't running through the center line right down to 0.000 degree, it's still going to work. I'm pretty darn confident about that. And so I'm going to get this as close as I possibly can, and then I'm just going to be happy with the results. I simply cannot see in behind there. So here's what I'm doing for my double check. Now I've touched my square off to this side of the wheel, and I'm going to very carefully back this whole, oops, it moved on me. Darn it. Okay. We can redo that. Let's try and hold that down a little tighter this time. Now I'm going to bring this way out here so I can really get my eyes in there, hopefully. Stop it for a sec. So again, this edge of the scale was touching the one side of my wheel. My hope is that the other side of the wheel is lined up with that center mark right about there. And now my double check is to take this piece of material, which is the same thickness as the wheel, gently lay it up against the scale and try and decide if that center line is about at the other end of this piece of material. Goodness knows I can't see any of that with my eyes, but I've reviewed the footage that we've taken and I'm happy with that. I'm gonna press on. Just before we get going here, I want to explain something that is inevitable with this setup. This wheel is way too big in diameter for me to create a flat bottom on this tooth seat area. So the bottom of this tooth seat area is going to be on an angle like this, which is going to cause my carbide bits that I make to want to tip. So I have no choice in the matter. I need the tiniest little 1/4 inch diameter slitting saw or something to do with this with, which I don't have. But my plan is when I make the carbide bits, I'm going to angle them on the bottom to match this angle here, and that way they'll sit decently straight. I'll leave a little extra for cleanup and it should all work out. 99% of the time I run my wheels so that the sparks, whatever's coming off them, is shooting down so I can collect it. Now that's not really practical here, so I am going to run my wheel backwards. One of the biggest reasons is there could be some cutting force here, and I don't want that cutting force loosening my nut and having this whole thing blow apart on me mid-cut. So because this is such a small amount of material that we're removing, I'm just going to suck it up. I'm going to run this thing backwards. The nut will stay tight. It will throw some of this dust into the air, but I am going to have my dust collector very close to catch a lot of it, and it'll move all the air towards it, but that's how this is going to have to go. Well, there's my two tooth seats. Pretty happy with that. Now I'm going to move on to carving out the carbide bits that I'm going to solder in there. All set to go for this next operation here. I've got everything centered, dialed straight. Everything's as straight and as dialed as it can possibly be. Now I've got this old end mill. Thank you, Tyler. This has been dedicated to the cause. It's about to give what's left of its life to this project. We're down to thickness now. I've got just enough space to get some solder in there. Now I'm going to start cutting off some blanks. So I'm set to start parting off these little bits. A wee bit nervous about this, just that concerned that this piece is getting, you know, a little on the flimsy side, but I think it'll be fine. Let's see what happens. I've got plenty of material there. If this doesn't work out, we can go to a plan B. Ended up with 4 little teeth, so that's 2 spares. I can lose one in the sandblaster, lose another one under the grinder, and that'll still give me 2 to finish this off with. Just knocking off these little itty bitty spots that broke through right at the end. Those are going to be fun to solder on. There's one ready. Well, I'm not especially looking forward to this process. I think it's going to take a whole bunch of tries to get it right.
And a little bit of patience.
Oh, there's going to be a fair bit of patience, yes.
But there's probably going to be a little swearing too, isn't there?
If your ears are delicate. Now, which side do I want to paint? So I'm checking to see if this actually worked. I can't tell by eye. I know according to my dial calipers, I have 20 thou to go on the inside dimension, but that only counts depending on how far the teeth are from each other. Kind of hard to explain. Anyways, I'm at 0. I'm on the leading edge of the inside of this tooth. I'm going to go to the opposite tooth, and I'm at -7. Now, I know I have 20 thou to go, and this is telling me that the first 7 thou I take is going to be off of one tooth only, but that'll still leave 13 thou to go. So in theory, I'll end up taking somewhere in the neighborhood of 6.5 thou off of each tooth to bring me to my finished dimension. So that's telling me that this is going to work. This next part of the build has me a little concerned, and the reason is not that it's a difficult thing to do. I simply need to machine the inside of these carbide teeth, and I bought this diamond mounted point to do it with, and I plan to come in kind of like this. Trouble is, I thought that the construction of this was similar to the construction of this, where there's diamond abrasive seated in a bond. And that doesn't appear to be the case. I think what I actually ended up with was little sprinkles of diamond just glued on top of a metal cylinder. So first things first, let's see if this will even cut carbide. This is the same piece of carbide that I cut the tooth blanks out of. So if it'll cut this, it'll cut my teeth. Yeah, cuts it. Cool. I'm going to make this next setup off camera, then we'll come back. I'll show you guys what I have going on. I'm nearly set up here. The plan is I'm going to come in here and grind the inside dimension of these teeth with this little mounted point. Now I'm going to do my grinding on the back side because from where I'm standing, I'll be able to see what's happening much more easily. I do want this to be tapered. I want these teeth to be larger diameter in the back than they are up here at the front. So I've offset my motorized work head, and you can see I've got a little travel there on my dial. I also want this end of the mounted point to touch and the rest to clear. So I've got my spindle slightly this way, and you can see that on this dial here. It's hard to see that, but
yeah,
it's there.
I had a hard time finding it.
I'm going to do my touching off with the dust collector off because I want to be able to hear as much as possible. This diamond mounted point isn't going to enjoy me finding the bottom of this counter bore, so I'm going to just creep up to that just as easy as I can and hopefully not have anything too catastrophic happen. Well, so much for creeping up on it. There's the bottom of our counter bore.
Scared the crap out of me.
I'm coming outwards now, and there I'm touching the carbide for the first time. And we knew already that we were going to be touching one tooth more than the other. And we can hear that happening. Cleaned up, starting to clean up on this one, not all the way, but we're cleaned up all in this area. This one here, I hope the light is right. You can see we're cleaned up nicely all the way. And we were expecting the one tooth to hit first. I do need to determine now for certain that the inside of this bore is a slightly larger diameter than towards the outside of this bore. Now my telescoping gauge is way too big and chunky. That's not going to work at all. But I do have a set of small hole gauges, and so I'm going to try and get a feel here for our diameter of our bore inside and outside and make sure I do have that slight taper going on. I can already tell I do. I haven't gotten a reading yet, but it's flopping around in there, and as I pull it out, it gets tight. So I think we're on the right track here, but I'm still going to get these measurements as best I can. I find these small hole gauges pretty challenging to use. They require a great deal of feel, more feel than many measuring tools.
But I've done my best here, and it would appear to me that my bore is 5 thou bigger in diameter at the very far inside than it is at the outside, which is some, and so that's going to be just about perfect. I've gone a little more. You can see clearly now we're nice and cleaned up on both sides. Cleaned up all the way. I've double checked. I am bigger at the back than at the front. Now, these teeth are sticking out way farther than I want them to be. I really want them sticking up a bare minimum amount, maybe this high. So I'm going to bring the measurement in this area to the size I want it to be, and then we'll be finished with this setup. I think I'm on the home stretch here now. Got about 4 thou to go per side to get this to where I'd really like it to be. I've got this inside dimension to what I want, and I've got about 3 or 4 thou taper on the diameter, bigger diameter in the back. So that's what I want. So we're ready to move on to the next setup. I'm gonna get the next setup done off camera. I'll come back and explain to you guys what I've done. I've got this next setup already. Now I've reversed the angle that this is set at because now I want the back end to be smaller, but for the same reason, because I want the front to cut and the back to clear. So I've got a slight angle this way on my motorized workhead. My wheel spindle, on the other hand, is dialed in bang onto the table, and I've also dialed across to face my wheel to make sure that it doesn't have a high spot, say down at this end, which could reverse my taper. So I think I'm ready to go. Now I'll show you my gearing here for my wheel speed. I'm always talking about how these diamond wheels should go slow. Normally they should. That's for the sake of the diamond wheel itself. But today I'm going for finish, so I'm speeding this up an awful lot, and I'm also not taking much off. I will keep my eyes open for sparks. Sparks and diamonds never mix. That means you're hurting your wheel. Otherwise, I'm hoping to get a decent finish, remove this material, bring me down to my finished size, and we'll see how this setup goes. Outside diameter of these teeth is all done. You can see the finishes. Well, it's decent. It's no polish, but it's certainly decent. It's adequate, so we're going to go with that. So I'm going to tear this setup down, make the next setup, and then we'll get you back in here. With this next setup here, what I want to do is I want to open up a gullet in front of the tooth. I want to make a place in here for chips to go. This will give me a great deal of support behind my cutting edge, which is great, but this coming all the way back around, while it was great for positioning, helping me position this when soldering, now I need to put a gullet in there so that chips have somewhere to go and not just pack up and break. I've got my little gullet here, and I'm going to use this same setup to get both tooth faces all the way cleaned up. You can see this one's almost cleaned up, and this one's got a wee bit further to go. So I'll get both of those on index. It's only going to take me a thou or two to get them there. I fed in about 2 thou there now. You can see this tooth is just about completely cleaned up on the face. Now this one here's got a little wetness, but I don't want to thin these teeth out more than I need to, so I'm just going to live with that little wetness. I think that'll be fine anyways. So the next thing I'm going to do is tear this setup down. I'm going to make a setup for putting the actual clearance angles for the cutting edges on these teeth. So I'll be bringing the teeth down to size and putting the clearance angles on there. Now in a perfect world, this would be a nice radius that exactly matches the O-ring that it's going to build a seat for. But I really don't have a decent way of doing that. My equipment is well suited for doing 90 degrees worth of radiuses, like all day long. but to do a 180 really isn't possible. Now in theory, I could set up and do two 90s and then blend them together. I really don't feel that's worth the extra hassle. What I'm gonna do is make a flat for a third of this distance, and then a 45 degree on the inside for a third of this distance, and a 45 degree on the outside for a third of this distance. And that's gonna give me a tooth that looks a little something like this. So that's my first angle done, and you'll notice here I have a much more reasonable amount of tooth sticking up above the support area. So I'm happy with that. I'm going to move on to my outer and inner angles. I'm going to try and do this without hitting the steel body with the grinding wheel. Now it's possible that'll happen. We may end up with a little witness mark. It's getting kind of tight in here. Just going to see what happens. Starting to look like it's going to be inevitable that at some point I am going to run into the body of this thing with my grinding wheel. So we're going to have a little mark in there. It's not really going to have any effect on anything. It'll kind of be ugly to look at, but I think that's going to be about the best we can do. Nope, not giving up that easy. I had an idea. We're going to do a slightly different setup here and carry on. This looks like it'll work well for me. I'm gonna have plenty of clearance everywhere. Let's see how this little mounted point bit enjoys doing this. This seems to be working fine, but I do have too much sticking out here. I'm getting some chatter, so I'm gonna knock some off the back of the shank. It is bottomed out in my chuck right now. I'm going to knock some off of there so I can get in tighter, and we'll try it again. So we've got that internal 45 now. Before I change the setup, I'm going to run the dial on there, make sure I have clearance everywhere. I basically brought this corner over about a third of the way, and so I'll leave a third of this for flat and a third of this for the 45 on the outside. This little outside 45 here now is going to be my last angle that I want to cut. I've got it out of the machine now. Pretty happy with how it's coming along. You can see we've got our little flat in the middle, our 45 on the inside, and our 45 on the outside. And they all have a nice clearance. Earlier on I said I was going to use a drill bit in this thing, and I've changed my mind. I want to instead... Well, the reason I don't want to use the drill bit is it stops cutting somewhere down in here properly, and then it goes from hard to soft throughout this area, and I really couldn't have a pilot until I was up into this area where it's real soft. I think that would be wanting to do a lot of pickup and stuff. I think I'd also have like a stupid amount of drill sticking out of the end of this thing. I think it'd look kind of funny. So instead, I think I've got a better idea. I have a reasonably new end mill here that has one chip tooth, but it's not too bad. What I'm gonna do is I'm gonna put some lead-in angles on this and basically turn it into a reamer. Then I'm gonna use it to ream out my tool here, and then I'm going to install it so that the flutes stick out some. It can do some cutting, but well before the teeth get to the workpiece, this hard carbide shank area will become my pilot. I think I'm going to be a lot happier with this, so I'm going to get that all set up now. So here's my little side project, turning this slightly damaged end mill into a reamer, basically. It won't be a perfect reamer because it won't have round lands on it. It'll be able to cut the whole way, but we're rolling the dice here. We're going to see what happens. I am kind of all backwards here. The reason is I didn't want to make all this be backwards. It was easier just to run this upside down. So I'm going to make some cleanup passes here, and then I'm going to check to see that I have clearance properly, and then we'll carry on. So I'm hoping this works nicely. I hope nothing binds up in there. Hopes are high.
We're reaming. There we go. That fits now. I plan on that sitting, just about like that, so it can do any reaming it needs to do, and then it'll have a nice hard pilot to ride on. So that's good. Now what I need to do is drill and tap a hole for a set screw, and then I can grind a little flat on that carbide end mill, and this thing can be held in position then. I actually have a couple holes to drill and tap, but just to speed up things here with order of operations and so on, I'm going to get all my lathe work done and out of the way, then convert it to a mill, and then I'll do my drilling and tapping all at once. Earlier on I told you guys I was going to use this piece of brass for my depth stop, and I've changed my mind on that too for a couple reasons. One is this depth stop is going to be very small. It'd be a huge waste of material. This is my very last chunk of brass. I want to save it for something really important. And also, this depth stop isn't going to be the kind of thing that does a ton of work. It's going to be more of a visual aid to tell me when I've gotten to the depth I want. So I'm going to make it out of this reasonably wear resistant material called Cetol. Boring it out to size now. The length of this depth stop is pretty darn important because that's what's going to give us our depth of cut. This is for a 1/16 diameter O-ring, and I'm going to want this to cut about 50 thou deep. So let's see how far it is from there down to here. 1, 2, 3, 4, 5, 554, 555. So I am going to want my sleeve, my depth stop, to be about 504 thousandths long. I'm going to double check that. Make sure. Put the little chamfer on, give it a little style. I was just getting ready to set up to put a set screw in this thing, but geez, it's just kind of snaps right on there. And since all the pressure is ever going to force it against this shoulder, I'm happy with that. That's ready to be a depth stop. I'm not even going to put a set screw in that one. But I still need a set screw in this one, so I am going to have to set the mill up and do that. This is my last step here before assembly. I'm just going to throw some flats on here. I don't want this spinning in a drill chuck. That would make a mess of the shank and totally throw out any accuracy it had. Okay, well, let's put this little guy together. So I have a little flat on my reamer slash pilot. Just going to line that up with my set screw hole. Press that screw in there. Make sure everybody's happy. They feel happy. So that's good. Get my depth stop on there. Nice tight fit. Could just barely even get it on there. Well, here is our final product, ready to test it out. You can see in here, I hope you can see, these teeth are sticking up pretty much exactly 50 thou. That'll give us about 12 thou squish on our O-ring, which I think is just about right. And if you take a look down the end here, you can see we've got our area that cuts flat, our inside 45 and our outside 45. That'll give us the shape of the groove that we want. And I think we're ready to go. Give this thing a try. Can you see that well from there? Mm-hmm. Here, there's crazy light. Do you want to come here and see it?
I could see it.
So there you can see the gap.
Yep.
And when I do this, you can see the gap disappear. And that represents our seal. Success.
Woo!
Well, I do need to make my gullets bigger. You can see my gullets are right packed full of aluminum chips, just solidly packed. But that's an easy fix. We can just take that gullet and bring it all the way out to here if we want. That way there'll be a lot more room for chips and it'll cut a lot more freely. Well guys, I took it all apart, cleaned it all up. I've got it put back together now. I'm pretty happy with the results. There's zero damage to it. Now, we did just machine aluminum, admittedly, and I do plan on making most of these parts out of aluminum. Before I use it too much, I'm going to lengthen up those gullets so there's more places for chips to go without it packing in. But all in all, I'm pretty happy with this. I think it makes a real decent O-ring seat, and I think this will serve me well as I'm playing with these various hydraulic components in the future. So I don't know about you all, but I'm not going to be happy until I see this thing machined steel. First of all, we're going to deepen these gullets up, and then we'll get to that. Clean that up. Do this. Can you see a gap under that?
Yeah.
And when I do this, gap goes away.
Yep.
Here's our finished groove in the steel. I would call that absolutely mint. I'm happy with the fit of it. The O-ring seal seems to be just about right. And here's our tool. It's in excellent shape. There was zero damage done. I think this thing would machine steel all day long. Well, that's going to do it for this video. I hope you enjoyed. Thanks for watching.